Hello, everyone. How are we doing today? We're going to go ahead and get started with our fifth quarterly gathering. So just to kind of set the stage for what we're doing today, and a little bit about this user group. So we gather here to learn from one another in all things Power BI, and we also welcome 2025, and we hope that this year is going well for everyone. Personally, I want to begin by expressing my support for everyone that is affected by these wildfires. And please know that our thoughts are with you during this difficult time, and we stand ready to support in any way we can. We're going to kick things off by introducing our moderators. We got Jaime, Caddy, Dan, and myself. Daniel Martinez had to attend some pressing matters, but may join us later. So if this is your first time joining us, I want to start off by saying that this is a dedicated space for California Community College researchers and Power BI users to, one, share expertise, two, dive into collaborative learning. And this convening is your opportunity to discuss challenges, discover some new techniques, and see how Power BI talents are leveraging some of its coolest features. Today's topic, we are going to highlight something that was emphasized in one of the surveys we did. We are graced with Emil Mobarakshin, and forgive me if I mispronounce that. He's a research analyst at Los Angeles Mission College, and he is going to outline how their college is leveraging the STAR schema as well as some helpful DAX tips. So without further ado, Emil, the floor is yours.
Thank you, David, and thank you, everybody, for coming here and joining us. I really would like to express my gratitude to Jaime, David, Kathy, and Daniel, who's not here right now, for really jumpstarting this group. I really enjoyed watching the previous convenings, and I was really looking forward to presenting this on this topic today. And please note that, I feel like the field of Power BI is so vast that you can never stop learning. So I'm sure there are better ways to do. So I just wanted to share my journey with everybody and see if it can resonate with some of you. So we're gonna go over. So today, let me start sharing. Today we're gonna go and discuss the. If you don't mind, I'm gonna switch to using my avatar rather than my face, so it's hopefully less distracting. So today we're going to be discussing the power of the STAR schema and how it can be used to improve reporting in Power BI and make it more efficient. So the STAR schema is something that we see right now on the. Hopefully you can see it on the screen. If you don't mind, give me a thumbs up. So this is just a way to organize the data. The reason why, so we can use the data, we can present the data in different ways. I mean, usually we do some data cleanup, and quite often we jump to visualization from there. So once we have more or less clean data, we can just go and show it. But the STAR schema allows us to enhance this step. The reason I'm using the STAR schema is to move from more complicated data setup and DAX to make it more simple. I included some links to various videos that I found really helpful in understanding different aspects of this topic. So hopefully you can use it after the fact. So I'm not going to go into details, but anything that's underscored like this one is basically a video or a website that can be helpful. So it also helps to increase the efficiency of reporting. With the STAR schema, we can get in more data and make the reports work faster, which brings us to the point when it's a multiplier effect. You are one developer developing one report, but there will be hundreds of users and hundreds of thousands of queries to those reports that we're going to make. So really, anytime that we can make things to go faster, it really multiplies the effect hundreds of thousands of times. Also, it allows you to streamline your processes when you work with the data because you kind of break it down into smaller chunks and you can see all the elements and organize your data in a way that's easily accessible. And it helps you to troubleshoot and debug the DAX, especially when it relates to calculate. So there are different ways, like I said, there are different types of data. Flat file is basically, imagine this plain spreadsheet of data. That's basically a flat file. Star schema is something that I showed before. It's basically a few data elements that connected. And the snowflake schema is an extension of star schema that when the dimensions can have their own dimensions. So we're going to go through the constellation of stars that's including Power BI, and hopefully we're going to move from a flat file to a star schema travel. But before we go into actually doing the modeling of the data, we need to discuss what's included, what kind of data do we have, and how can we look at it. So in a Power Query, we're all familiar with the table. So think of it like an Excel spreadsheet, right? So the table, the Power Query can actually be used to look at this data in many different ways. So the simple values or numbers within each cell with the table, these are scalar values, and they make up the table. But there's a couple of other data structures in Power Query that can be used as basically like a list and a record. And those can be used, again, to improve the calculations. So we're going to jump into looking at those basics. So right now I'm in the Power BI, and I'm going to open the Power Query editor so we can look into a little bit more details. Like I said, the scalar is the simple value. It could be a number, it could be a text, could be anything. The table essentially is a set of values, right? So it has the rows and columns. Whereas the list can be just a plain column you can think of it as a plain column of data. With the Power Query, you can make it a little more nuanced, and you can actually embed the whole tables within that column. So you can see there's a table underneath. Let me know if you can see it all right, or if you want me to zoom in a little bit, David. Is that better?
Yeah, that works well. Are you able to zoom in just a little bit? If not, I can still see it.
I can do zoom in more. Better?
All right, perfect. Thank you so much.
Awesome. Okay. And so the list can have tables or rows or just values of the different kinds. Whereas, but in the table, generally speaking, we prefer to have the same type of data in each column. And then the record, finally, the record is something you can think of it as row. Even though it's displayed vertically, you can think of it as a horizontal row of data with the headers. So, like I said, those are different structures that are available in Power BI that we can use for our purposes, and we can make. So the next step that I want to say is with the data we can. We're going to use it in our exercises. So with the data, when you have a table, you can make a duplicate of the table, or you can reference. And in the beginning, I was really puzzled with what's the difference between those two. But it's actually quite straightforward. When I'm duplicating the data, the Power Query is really powerful in the sense that it actually allows you to record all the steps when you make up a data. So here I started work with the list, and I just made some modifications, sorted it, converted it to a table that has a column, renamed the column, and changed the data type. So whenever I do a duplication, I'm making a copy of those steps. Whereas if I'm making a reference, I can start off making a reference by making just a blank query. And in that blank query, I can just type equal sign and name the table that I want to pull. And I'm going to pull the table. And as you can see, all the steps that made up this table are gone because we're looking at the final product of that. That enables us to make some pretty cool things with the data. Also, I wanted to discuss the sort of the data types that we have. So the data types we can have different types of data in the Power Query. I mean, in our table, and those different data types can take a various amount of space. And for the Power Query, it's actually I'm going to switch back to this for a second. So different data types, like I said, we as humans understand words better than numbers, but the computers is the other way, right? They understand numbers better. So ideally, we want to bring the data in a format that computer will make the most use of it. The logical data, yes or no, can take just 1 byte. The numeric data, any numbers that includes dates and date times, it takes up 8 bytes of space for any numbers up to 19-digit long. And if we're going to take text, the same 19 character long string will take up 38 bytes because it's 2 character per bytes. So whenever we work with Power Query, we want to really kind of cut it down in the way that so we ingest as little data as possible. So we filter, we remove all the rows that we don't need. We also remove unnecessary columns. If we have any columns that we don't need for analysis, we can take them out. We try to use the simpler data type, logical or number, as opposed to text. And we try to group and summarize data and process it in chunks. And so think about it as your rocket fuel. Whenever you travel, you only take just as much as you need, not too much more, because any extra weight you carry will slow you down. So because the Power Query process data in memory, it means, if the data set is bigger, it will run slower. And same applies for the DAX. So, okay, coming back to that data point. So this is the sort of different data types that are available in Power Query, logical, text, etc. So if, as one example, I can show that if I'm going to take, I can make a simple list. And in the Power Query, I can make a list very quickly with, say, 1,000. I can make like a really long list very quickly. If I can take, let me just take, okay, so here's the list of numbers. And I'm going to make the list from 1 to 1 million. That's 100,000. So this list now contains 1 million rows. I can convert this list. I can make it into a table. So now it has a column. And what I'm going to do, I'm going to just duplicate this column. So I'm going to have exactly the same column. But the first column, I'm going to call it number. And the second will be text. So we have exactly to the same, the data essentially hasn't changed, right? All I'm changing is the format. So here there's a whole number, and here we have a text. And if we're gonna save that data, I'm gonna close and apply, and I'm gonna run a tool that will hopefully help us to display why having a correct data types makes a fairly big difference. So I'm going to attach it to Power BI Basic, and you can see that the numbers data type, so the numbers size is only 3 kilobytes, whereas the okay, I don't think I ingested it. Hang on a sec, sorry. It's numbers. I need to load it. I'm sorry. So list numbers goes inside. So we're processing 1 million rows. We loaded them into memory. And if I'm gonna refresh the model here, it shows that the text takes 48 megabytes of memory, whereas the number column only takes 6. That's a really kind of quick example to see if we can have the same data in the simpler format, our Power BI will work faster because we have to take a lot less memory. Okay, now we can move to next step. So when we have once we have the data, we can model. So modeling is basically a simplification of the real data. Like George Box's decision said, that all models are wrong, but some are useful. So because we take a data set that describes something, we can simplify it in a sense that can make it more meaningful. So we're going to start with the flat file that we import from CSV or Excel, and we're going to build a star schema model in it. So we're going to go to our second Power BI, which is the flat file. So this is flat file. This is something that we're all familiar with. And if I'm going to go back to Power Query, we can see that this is just a plain Excel file that we have imported. or rather CSV file. CSV are actually preferable to Excel because they, again, make a small improvement in the speed. So here's the data set that contains some completely fictional information about students taking classes in the various courses, whether or not they were successful. So I would like to share like this. The Power Query has a lot of interesting, very useful function. One of them is that I found particularly useful is the table.profile. So if I'm going to take table.profile, what it allows me to do, it takes the table as an input and then makes a really, well, fairly quick summary. I mean, I have like 4 Power BI models loaded right now. It makes a really quick summary about the data that's contained in this table. So we can see there are 14 columns in this data set. We see the minimum and maximum values as well as the averages if the numbers are numeric, standard deviation, etc. So it allows us to look at a very quick snapshot into data to see if there's any distinct, to see if we have any null values, how many distinct values we have. So for example, for academic year, we have 111,000 rows plus, but there's only 7 values that varies, so which is like perfectly normal. Same applies for most of the columns. So rather than having a long table with a lot of data, we're gonna make this table into dimensions and facts. And again, I'm gonna use that reference technique that I showed earlier. So the way we're gonna make it, we're gonna make a new query, and we're gonna reference that query that we just used. So basically, I'm loading this table, and I'm gonna uncheck enable load for the original table. So we're not gonna, because we're not gonna take it into Power BI. We're only gonna take the improved version of that table. So if I take this table, I can make modifications with it. So let's talk about the dimensions that we're going to build. So dimensions, you can think of it as a lookup table. So looking for the data, we often use the lookups. And those are generally tend to be wider tables that have a lot of textual data. And you can think of it as a different sort of categories of data. In this case, so we're looking at the space where the class took place, time, year, or semester, what kind of academics, so they belong to a class, belong to a particular department, subject, and course. And we also think about the student, what was their age, gender, ethnicity. So when you look at these dimensions, when you look at about dot, let's say this is a student. If you look take one dimension of age, we can think of this student being somewhere on this ridge, somewhere where his age is. We're going to take the 2-dimension age and gender, then it's going to be somewhere in this square, so some dot in this square. And then the 3-dimension goes to, when we add the ethnicity, we have the dimension, some dot in a cube. So you can think of this basically as different characteristics of the students. And that's what we're going to try to use, just take out those dimensions and look at them more clearly. Also, we have the second portion of the star schema is the facts. The facts are anything that's numeric and anything that allows us to somehow describe those students. How many classes they taken successfully, how many classes they were enrolled in, how many awards they get. So, and we're going to take we're going to build the measures based on those facts. And we're going to build a very basic measures, and then we're going to make a more complicated measures using those original measures as building blocks. So I'm going to show you an example of how we're going to do that in the Power Query star schema. So now when I link to this original data table, what I can do now, I can make it into dimension. So for example, if I want to isolate a location, and there are 2 ways to do it. I can either remove all columns, then unduplicate data, remove duplicates, and it's going to give me just a list of the unique locations that this data set contains. But I prefer the other way. I prefer to use a group by feature, which you can think of it as a very quick pivot table. So if I take a location and I use the count of rows in this original table, I'm going to get a very quick summary of like how many records do I have in this table for each location. So I can see on campus is a lot higher than, let's say, offline. Offline being dual enrollment type of classes. The next step I need to do, because I need to have some sort of identifier, numeric identifier. So what I'm going to do, I'm going to add the column, index column to it. And I can use 0, 1 because the Power Query really starts 0 base, but I'm going to just use that. And I can use the the formula bar to actually say, okay, this is going to be the location IDX. So this is my index. So instead of having the data like in the text format in the original table, I'm going to have it in the different format. If you excuse me for just a second. Okay, apologies. So like I said, so instead of having the campus online and offline, and so this is going to be a dimension. I'm going to rename it to be dim loc. So this is actually, I should have called it like probably dim location, but that's okay. So I'm going to make another. So now I'm going to just show how, I'm not going to do it for all of them because this is fairly repetitive process. I'm just splitting out different pieces of information of the into dimensions, and then I'm going to leave the fact table. So I'm going to leave the all the fact table only going to have the numeric values. So I'm going to show you the example of how it's going to go. So now I'm taking the original. So I'm going to rename that right away to be FCT data. So this is the factual data that we have about students. So now we have the campus and online. What I'm going to do, I'm going to merge this table with the table that I just created. So basically referring pretty much back to itself. And I'm going to say, okay, I want to match it based on the location. So it will do the check and say, okay, all of the records are found basically in the both tables. So we have the complete match. Now I can go back to this table that I just, go back to this link that I just created, and I can expand it and only take out of this. I don't need any of this because they kind of repetitive. So I'm going to just take the location index. And the last step that I'm going to do here, I'm going to actually take out the location because I don't need it anymore. I'm going to remove that column. So I basically will do this process for every single textual column in this data set, replacing the textual values with the numeric attributes. And I'm not going to bore you with like doing it on for four different times. I'm just going to show you the end result of what it's going to look like when I'm done. So once I'm done processing those steps, so model flat, I'm going to close out the title page so that I don't get lost in my own Power Queries. I'm going to close and apply. So here it will replace, basically it will take out the location and add this index. But I'm going to, in the star schema file, I'm going to first jump into Power Query again and show what those tables look like. So now I have 4 dimensions: collocation, semester, time data, academic organization. That includes departments, discipline, and the course, and also age. Even though I could potentially separate the age, gender, and ethnicity into their own separate. Okay, I don't need that anymore. Save it. So even though I could potentially, even though I could potentially separate the age, gender, ethnicity into their own table, I always like to have them in one table whenever possible. There are some exceptions to that, but whenever possible, I like to have them in one table because when you think of a student, you never think of it, oh, this student is just 17 or under, or this student is just female or something like that. The student must have all of these characteristics. So this is more or less complete picture of their demographics, right? So when you look at this, we have 177 students that are 17 or under, age, gender, and Alaskan Native in this data set. Actually, this is actually enrollments, not the actual student, because I'm not talking about individual. This data repeats over semesters. But anyways, that's being the point. Like, so within that semester, we had X number of students in those 3 categories. So now when I broke out the dimensions and the facts, I can again unload, like I just uncheck I enable load, so this data will not be loaded. So all I'm taking with me is 4 dimensions and the facts, right? And if I'm gonna go to a third tab, which is the model view, now we're gonna have our power scheme, star schema, I'm sorry. So, and as you can see, it kind of resembles the star when you have factual data kind of surrounded by different dimensions. I generally I actually prefer to have them kind of on top, because this is the way that the data flows. So as you can see, these actually arrows have they actually have meaning. That's the way that the filtering works. So like if I try to filter data going from age to academic work, I would have to use some functions to do that. Anyways, so this is the star schema. Now we have the star schema, we can go and actually make something useful out of it, because so far we've been just working with the data, right? So as you know, in the Power BI, we can make calculated columns, which essentially would mean we would just take some sort of calculation and add it to the original table. And in some cases, it can be useful, especially when you need to do some filtering of the data, if you're just trying to sort of group some data. But generally, like if we're just talking about some sort of calculation that we're trying to do, it's best practice to, rather than doing the calculated column, we should try to do a measure. The reason for that is calculated column still takes up memory. And every time we work with the data is being refreshed for the entire table. Whereas if we make a measure, we only show this data once it's actually needed. So let me go to the DAX piece. Well, actually, I'm going to start from the star scheme. So now I have and again, just adding the calculated column. So if I look at the factual data here, I could add a new column here to calculate, for example, I could add the calculated data to say, find the ratio of success to enrollment, which will be either 0 or 1, because it's for each enrollment. Or I can do that as a measure. And that's what I'm going to do. I'm going to actually create a measure for this table, for this schema, a very simple measure that is basically the enrollments. If you think about granularity of the data, of the factual data that we have in the fact table, each row in the original table and in the star schema is basically the same, and it basically represents an enrollment. So if I can just call this measure an enrollment, and I can just use the sum function to say, okay, I want to see all the enrollments. How many enrollments do I have in the table? And I can take this data, or this measure, and put it on a card so I can see this in this data set, we have X number of enrollments. Now I can branch out or build up on this measure to say how many of those enrollments were actually, I'm sorry, the successful enrollments. This would be a sum of the success, because we do have that data in the factual data set. And I can add this again to the original table that we have. Now we have two numbers, and I can easily calculate the success ratio, which that's where we start to branch out the measures. So now I'm going to take success rate and calculate it as, I'm going to use a divide function because it allows you to handle zero, divide by zero cases. And this is how I'm going to build up the success rate. Now, it is important to calculate, to format the data properly and name it properly, because otherwise we're going to end up renaming and making changes in every single visual. So it's easier to do it from the start. So for success rate, I'm just going to go and pick up this as a percent sign, because that's how we normally show the percent. I'm going to leave just one decimal point, and so on and so forth. And I can do the same for the enrollment. So it'll be a whole number with the 1,000 separator. I would have to modify the actual visual to show it as like without the kind of a rounding to case, thousands or millions. But basically, that's the way we would go about making up different measures. Now, I just show you, so like, sometimes I mean, we can do easily do the calculation in sort of different ways. If I take just the enrollment and drop it in that visual that I have, I'm going to get the same kind of enrollment. I'm going to come down to the same number, 111,484. Now, the difference is this calculation only exists in this visual. So I cannot reuse it, unlike what I showed just before. I cannot take this calculation out of this visual and put it into something else. I would have to start all over again. I would have to do all the formatting again. So that's the reason why we should never use implicit measures and only make the measures in explicit. We should name them so it's easier to understand, because we can end up building a lot of measures. We should format them properly so we don't have to do it on every visual. And ideally, we want to organize them into a measure. Think about flood table when we had those different rows. So the difference between using the flood table versus star schema. In the star schema, I can see all the data that's related. So for example, Asian ethnicity, I can see all the columns that are related to that in one tables. Same goes for the semester or location, etc. Whereas in the flood schema, you would have all this table, all the columns mixed up together. So we have to scroll down and find each and single one of them. So that makes it easier. Using the star schema makes it easier to look at the data kind of organized neatly. And for the same reason, I usually like to move all my measures into their own table that would have just all the measures. The way to do it is basically we're creating a new table. And if I'm going to make a new table and I'm just going to make it blank, I'm going to call it, for example purposes, example. And I'm just going to leave example equal. So it's going to make an empty table that has nothing. But once I take one measure and change its location to be that example, it's going to move that measure into this example. And once I hide, notice how the, so right now it shows kind of a table sign here next to the dimensions and the facts. And so is for the example. But if I'm going to take this single column that it has, and I'm going to hide it, leaving just a measure, the sign would actually be supposed to change. It's okay. So again, so now I organized my data in the way that it sits in their own dedicated tables, and I can just work with them however I want. So I'm gonna, so and this is actually where okay, so let's check how we're doing. So we can also use the variables to I already showed the example of chaining or branching measures when one measure is being used in another measure that can kind of build more complicated cases. We can use variables to break down the calculation to pieces, and this is sort of what I'm partially doing. I'm just doing it in different measures, whereas I could just build it into one. I'm not going to talk about time intelligence and dedicated timetable, but usually if you work with any sort of date-related data, then you should really consider using the date table for that. Now, I know oftentimes it comes up that the DAX is very hard. Because and it is hard. It's not easy. Let's put it this way. It's not easy, but it is pretty simple. And the reason for that is that DAX that takes the entire table and then the measure compresses that table into single value that we display on a visual or in a matrix or in a table. And when you use calculate, because it changes the context of calculation, it can make it even harder. So there's a different way to use that. If we think about star approach to using DAX, when you use the variables, when you take a table, you transform it, aggregate to a number, and then return the results. That's how you do it in one in one go. So, and as an example, what we're gonna do, we're gonna calculate PPG -1 here, and the way we're gonna do it, we already calculated the enrollment, we calculated the successful enrollment, we calculated the success rate. Based on those measures, we can calculate other things. We can calculate the other elements that we use to calculate in PPG -1 is the enrollment of students in other groups, the comparison groups. In this case, the same for the successful enrollment and obviously the success rate. And then we have to get the PPG -1, and we're not going to go into margin of error calculation because we're probably not going to have time for that. But you can easily kind of extrapolate and use that for your own calculation. So I'm just going to go over the calculation. And like I said, the enrollment is basically, I could use either some of that factual table enrollment column, or I can count rows because it's the same thing. In this case, the number of rows would be equivalent to the number of students enrolled in those classes. Based on that, we also calculated the success. So that was, and here I use the calculate. So here I use the calculate and I use the modify the context. I'd say, okay, calculate the enrollment, but before doing that, filter out only rows that have success equal 1, which in our case means the student was successful in this course. So, and then like I showed, we can calculate the success by just dividing that one measure over the other. Now, when it comes to calculating the other groups for the other students, we have to modify the context. So when I do this calculation, I use another function, DAX function, that's called O. There's about 4 or 5 different functions in DAX that begin with O that can be used in different cases. But basically what this function does, it removes the filters. So when we look at the data, when I calculate the data in this table, whenever I calculate it here, if I'm going to show, if I'm going to decide to show the enrollment of others here, it's going to show me 0 because it looks at the entire data set for this particular semester. It looks at the entire data set and say, is there any other? No, there is no any other. But whenever I break down the data by some group, for example, by the age group, I can see, so if I have 8,000 enrollments in this semester, 8,106 in this semester, out of them 1,793 were 17 or under. To calculate the other, I need to remove the filters from that data and say, okay, give me all the enrollment, so in this portion, I'm saying, give me all the enrollments regardless of whether or not there was 17 or under. So basically here I'm taking this 8,000 number. If I would just show, let me do that. So it's actually more clear. Because here I'm combining, in this calculation, in this measure, I'm combining 2 calculations. But for the illustrative purposes, I think it's better to do it. So measure all. So all enrollment. I'm going to add this calculation to this table, and you will see that here it shows me, for this particular semester, it shows me all 8,000 enrollments. If I'm going to change the semester, because the filter is kind of a different other thing that impacts the visuals on this page, the calculation will change. But for that specific semester, it will take just that one number. So the enrollment other would be the number that shows me this is how many enrollment I had in all other groups than 17, because I take the 8,000 and I subtract the enrollment within the group. I do the same trick with the other, so I get the number of successful enrollments in the other groups, and then I use the success rate calculation for the other, basically the same way. I just take the division of the success other divided by enrollment other, giving the 0 as a kind of a fail safe. And then PPG minus 1 calculations couldn't be simpler. We just take the success rate of the respective group, and we take out the success of other to identify what the gap is. Now, I also added kind of a neat trick that I really like to use, and this is using the parameter groups. So I created a parameter. I can do it again here. If I go to modeling tab and say, I want to use a parameter as a field. And for that specific case, I'm going to just go again and use this because I based the calculation. I created a parameter. And it's going to ask me, like, do you want to, so it adds me as a table, and it gives me this option. So if I'm going to, in this table, if I'm going to take out this, let me make a copy of that. So let's see. So if I'm going to use, instead of demographics, I'm going to use the parameter here, put it up front so it's easier to see. And I'm going to take out the all enrollment because it clogs up the space. So here, right now, it shows me everything. So it basically expands the table to show me all the age groups, all the gender, all the ethnicities, and it does the same calculation. And I can actually, like in this particular case, I made it a single select. So I can, whenever I do the calculation on this group, I can change what I'm looking at. here I can change by using different parameters. I can change the calculation to show me. You don't see me smiling because I had to move all the visuals on this page, but I can change the calculation. I can look at the same calculation based on different demographic characteristics. I can look for gender, ethnicity, or age group, whatever I want. If I use it as a multiple field, I can combine two and say I want to use at age and gender at the same time. So I'm taking age, gender, and I'm calculating, basically the same numbers and comparing them to the other group. Okay, how am I doing time? 15 more minutes. Okay, so right. Let me jump because I'm getting to weeds. I'm going to jump into this one. No. Here I'm running a little short. So, okay. So we saw how we can calculate the PPG -1, right? Now, there are other elements that we need to think about when we making up the report, design elements. So depending on the business rule, depending on the role of the user, we can present different information. So let's say a department chair can look at the difference at the data differently that, let's say, VP probably want to have more aggregated data, and the faculty member may want to look at just their own specific class. So different reports will have different purposes, and we should have, a clear audience in mind when we make them. The other rule is that, the kind of a combination, actually, 5-second rule or 330-300 rule. It says that we should layer the information. Remember, I used those big numbers to show just a summary. This is like a 3-second rule. So when you come to the report at 3 seconds, you can see the most important information. In this case, it's how many enrollments and what's the success rate is. In the 30 seconds, we can go and switch it, maybe different filters, and say, okay, for a different group, we will have different numbers. And then in 300, we can really kind of dive into data and look at it. Again, we try to keep the data as simple as possible and try to keep the design of the reports kind of consistent, both within the report as well as across the reports within the organization. If you have multiple reports, it's better to make them look alike so people kind of feel very familiar. So that's where the themes come into play. But I'm going to just start with the visuals. So, okay. So here's the table that we started with. The table was somewhat complicated. I mean, it's a lot of numbers, right? It's difficult to look at those numbers and make some sort of decision. And oftentimes we're going to do a chart. Okay, this is the chart that shows the success rate, and we can break it down by different age, gender, ethnicities. And why not throw in some color for good measure so they, it looks funnier, or looks more festive, right? The problem with using or overusing the color is that it kind of hides the message, and it kind of detracts the user from their purpose. In this case, they're not necessarily looking at different all the different groups. They may be looking for something else. So in this case, they're probably looking at, let's say we take an average of all of them. So for all of the group average, it was 48%. Is this specific group higher or lower? It's kind of difficult to see here because the numbers are they're pretty close, right? So we can take another step and take out all these colors and just put the average as a bar right next to it. So it's a little bit more clear. But again, we're probably looking just at the difference. So why not just look at the difference? Why do we need to look at the specific group? Because if we pick a specific group, let's say Alaska Native, we will see their success rate. But here we also see the difference between the Alaska Native group and all others. So we can see the data more clearly. And finally, we can use the color to actually really emphasize the point and say, when we're looking at this report, it just drops us, okay, these are the red bars, these are not good. This is something we have to pay attention to. And we can add more information using the tooltips, etc., to really kind of provide more context for the users to make their decisions. But ideally, we want to have very clean, simple measures, very clean, simple visuals that convey the message as effectively as possible, without overloading the user with a lot of details like in this table. Okay, so now the next step that we're going to talk about is using the right visual. There are about over 200 visuals available in Power BI, including the custom. And for different purposes, the different visual serves, work better. So the ones that I use the most is the cards that shows the single number, just a summary. Horizontal bar charts I prefer to vertical because the vertical we are sort of trained to look at any data that goes vertically, horizontally, to look at the horizontally data rather than bar charts going left to right. When we look at the data, sorry, yeah. So horizontal bar charts are better for comparison, whereas vertical bar charts or lines are better for trends over time. And when we look at the sort of whole parts to whole ratio, I prefer to use tree maps, but the pie charts or donut charts can have their value. And like I try to use the tables and matrices only when like there's a lot of data that needs to be displayed and it's just impossible to put it into a visual. So pick the right visual. Now, when it comes to color use, I just showed how we can use the color to emphasize the message when we display the data. So, but we should use it consistently across different fields or categories. So I try to use as little color as possible and only resort to it when I need to display the data. When I really need to kind of drive the point. We also want to use the color-friendly palettes, ideally, that shows the data that's color-friendly blindly. Okay. And we don't want to use the broad. I wanted to show the different color perception, but I think I'm going to be running out of time. And I really wanted to do a couple more things. So, okay, the final step in our Power Star journey is like we started with the data, we organize it into data model using the star schema. We made the calculations using the DAX measures that really kind of, when I think about it, it's like star. We start with one measure and it expands into many more. And then the final piece that really helps to makes it easy on the formatting is using the themes. So here I show you the final example, but if I'm going to go to the original one, I can go to views, and I really like to use that theme kind of consistently. So rather than looking at this plain vanilla report, you can use your institution color schemes, color palettes that really kind of like combine the data and make it look very nice and kind of cohesive. This scheme is not perfect. You will see some gray areas, but generally you get the message. So like I usually end up with something looking like this. That is simpler look. It's not distracting. And like I said, this is our institution's colors. So we try to use them to make the users feel at home whenever they use them, whenever they use our reports. Okay. And now the final point that I wanted to say, I want to leave a few minutes for Q&A if possible, is that really there's a lot of data that we can use. I think I use this one better. Okay, so I put a few links that I find very helpful. There's a comprehensive Power Query guide if you want to learn more about how to use the Power Query. So there's like all description, all the functions that they have. There's formatting that makes it really easy to format the Power Query queries. There's really interesting video about Roche's maxim of data transformation, and like I mentioned, latent information 300 rules, and there's some links, references to different types of Power BI visuals and when to better use them. Okay, and I think with that, I'd like to stop and probably take some questions if you have any. Should I stop sharing, David, or keep it on for now?
Oh, you can keep it up. Thank you.
Okay. All right.
I'll go ahead and start us off. Well, thank you so much, Emil, for sharing. I actually learned a lot about that. I haven't used star schema as much, so I'm just curious to know your thoughts on how flexible are they? Let's say we need to go back and make a modification on some of the data. Are they pretty forgiving, or do you have to restructure the whole thing all over again?
That's a great point, David. Thank you for bringing it up. And I was actually going to show something that I forgot. So like I was saying, using the star schema makes it really kind of, because ordinarily when we have, let's say we have a new data, right? We have to import it and do all the same steps all over again, right? So in this case, star schema can help us in some different ways. So for example, if I have that flat table that had the data, Give me just a second. I'll move the Zoom controls. So I have the data. If I look at it, it refers to data piece. I can duplicate this data set. And the fall 24 just finished, right? So I want to go back to the fall 24. And instead of, recompiling the data manually, I'm going to create in fall 2024. It updates the data based on that file. I should probably name it better. So let's call it fall 2024. So we have exactly the same data type that we had in all our previous, I want to say 6 or 7 years, the data that I generated. Now in the load table, remember I was referring to flat table. So what the Power Query allows you to do is just merge them really easily. You can use append queries, but I find this method is much simpler. So here, when I'm not hitting enter, but rather checkbox, I'm going to add this. Now, the original, like I said, the original data table had all the terms going to fall 23, or rather summer, I don't know, summer 24, I guess. Yeah, so it's up to summer 24. There was no fall 24 data. That was the original data set. Now, when I combine those two tables, flat table and the fall 24, if I go back to looking at the terms, now I probably need to do a refresh. I'm sorry. So I can do the refresh because it takes a second to calculate. Refresh preview. It's stubborn. Oh, load more. I'm sorry. That's what I should have done. But basically, it's going to redo the calculations. I mean, redo all that steps. And now we have the 24 data available here. So now it's, we can keep adding up the files and expanding the thing. And because all the calculation for the dimensions actually based on that table, we don't have to do a thing here. It will take whatever new values come in and it will interpret them. Now, there's some exceptions, obviously. I mean, in some cases, you may have courses or subjects changing departments. You may have to make some decisions about it. But we decide, one of the ways you can deal with that is you can say, okay, whatever is the most recent department organization is, that's what I'm going to use. Because I don't want to be, let's say, have computer science to be in the math department 1 year and in the computer department another year. But it's up to you. You can have them in 2 different departments. So, but yeah, if you use this, I mean, like if you think about like consistent data structure and nothing much changes, star schema works wonders. The other way to deal with that is to have comprehensive. For age, gender, and ethnicity, what I actually try to build up a comprehensive table that includes everything, including the unknown. Like if I don't have the data, I will have the unknown row for that. But it could be unknown for age, gender, and ethnicity, but it is a category for the student. So, but because it's all encompassing, I don't have to go and modify the data. I actually don't have to write all the steps. I just make up the table, load it, leave it there, and I don't have to update it ever again because it includes reference to all possible combinations. Does that answer your question?
Yes. So I just wanted to know your thoughts on it. But yeah, thank you for explaining.
And the other thing is like, because it's a star schema, right? When you think about flat table, you mentioned something about expanding. When you think about it, it's a flat table. When you have a flat table, I know in some of the previous convenings, somebody mentioned that like our file data structure has changed and we now have like more or less data, more and less column coming in. The flat table allows you to accommodate in a way that, like, if I have additional column of data, let's say I want to add the major to it, I can just calculate the major for every student within the semester and add it as an additional column or as additional lookup table, and I'm done. I can expand it both. So I just showed you how you can expand it horizontally, add in more rows, but you can also, vertically, but you can also expand it horizontally to add more characteristics, or to have more calculations. Let's say you want to add just to enrollment and the success, you want to add the persistence, you can do that.
Well, thank you so much, Emil. Do we have any more questions that we'd like to ask before we conclude today? All right. Well, thanks again, Emil. I want to just take a few minutes to explain what we're going to do for our next meeting and kind of close up for this meeting as well. Uh, First off, we are going to have our next meeting. It's going to be the same sort of structure as before, the fourth Thursday of the month. So that's going to be April 24th at 10 a.m. We're also going to provide the meeting recording and the PowerPoint presentation or the PDF version on the Fabric webpage, as well as the video on the YouTube channel. Lastly, for our next meeting, we'd like to just take a few moments to kind of gather some of the interest points that anybody wants to learn more about. So go ahead and take a few minutes to just type in the chat which areas you'd like to know more about and what you'd like to see as possibly the next presentation topic. And while everyone is doing that, we were discussing creating a shared resource. Um, Perhaps including DAX. So if anyone has, let's say, some favorite DAX that they like to use, we're going to create a most likely a Google Share Drive location where you can share, and then we can all see, what other colleges are using in their Power BI DAX. That might be helpful. So keep an eye out for that. We're going to send out more information soon, but that is in the works.